Good morning, everybody. Today is Friday, October 15th. We still have quite a few people who are absent, and so I'm going to continue to make these videos just summarizing what we did in class that day. All I need you guys to do is just watch the videos just so that you kind of know what's going on in class and you're a little bit better prepared when you come back, okay? So today we are going to continue in plate motion. Look up at the top left of this screen. You'll see we're in lesson 1.3 still. Yesterday I had a field trip, so I was gone. It sounded like a lot of kids kind of struggled a little bit with the material while I was gone. So I'm just going to review the main important parts, making sure you guys understand the information I need you to understand from lesson 3, and then we'll move on to lesson 4, okay? So we're going to talk about patterns. And some examples of patterns. Today in class, when I was talking with my first period class, we talked about patterns, and an example. A pattern is something that happens over and over again. And an example would be like a checkerboard, how that pattern of black and red squares that happens over and over again. Of course, your vocabulary word for pattern is something we observe to be similar over and over again. So I wanted the kids to take a look at this and notice that we've got, if we took a map of the earth and we kind of spread it out flat so it's two-dimensional, this is a map of the world, okay? And you'll notice that we have these kind of areas, A, B, C, and D, and we notice that there are these red lines here. The red lines indicate a plate boundary. And we know that Earth's outer layer is made of hard solid rock, and it's divided into plates, and these plates meet. It's not like there's gaps in between the plates at all, because they're not. So where the plates meet, and you can see those in the areas A, B, C, and D, every place where one plate meets another plate, that's called a plate boundary. And so on this map, if you look at the bottom left, there's our key, and we can see the red lines are the plate boundaries. Now, if I continue, I want to ask you guys about earthquakes. What happens during an earthquake? Somebody in first period said, well, the earth shakes. It's when the ground moves. And that's exactly right. Our vocabulary term earthquake, the definition is a sudden shaking of Earth's surface. And so I've got another map, and I've got these little earthquakes. If you look at the bottom left, we see the key. These are earthquakes from 1960 to 1990. And notice that Amplify uses a black dot to represent earthquakes. And an interesting thing happens. When I put the earthquakes and kind of put them on top of the plate boundary maps, we notice what's called a pattern. The pattern is that we see earthquakes occurring at or near plate boundaries. Now, there are a couple exceptions where we see maybe an earthquake. Look in area A in the big part of the plate boundary. You see some earthquakes that are occurring that kind of look like they're not near a plate boundary at all. But remember, this occurred over 30 years, and the plates are moving, obviously. And so this happened near enough to a plate boundary that it does fall within this pattern. So the pattern is that earthquakes and plate boundaries occur at the same place. So why do you think that happens? What do you think what's going on? In order to answer that question, we need to make sure that we understand some key concepts. So if you don't have this written, I want you to pause it, go into your good notes, write down key concept number 2, and then when you're finished, go ahead and come on back. Key concept number 2 says Earth's outer layer is divided into sections called plates. Okay, I have a third key concept for you. Key concept number 3 says geologists look for patterns in landforms and in geologic events in order to better understand Earth. And that's true for, yes, earthquakes and plate boundaries, but think back to what we did in the Geology on Mars unit when we were looking at landforms and we were looking at like what patterns did we see so that we could say we think this is what caused it. Even the formation of conglomerate rock, that's a pattern that we look for. And because we're able to see that pattern on Mars, that's another reason why we were able to come to the conclusion that water formed the channel on Mars. So go ahead and write down key concept number 3. Geologists look for patterns in landforms and in geologic events in order to better understand Earth. All right, so now we're going to go to lesson number 4, and we're going to pick up, this is what I want to do today. Let's see if I can get there quickly. Oh, perfect. Hang on, you guys. Lesson number 3, good. All right, we're going to go to lesson number 4, and I'm going to present like the bell ringer. I'm not going to have you guys do the warm-up individually. Let's go ahead and do it together, okay? So the warm-up for this is, we want to know, now that we've identified that earthquakes happen at or near plate boundaries, we kind of need to figure out why. What's causing the earthquake, or what does the earthquake cause to happen? So if we look at claim number 1 and claim number 2, just for this lesson today, the question is, what happens to Earth's plates during an earthquake? And claim number 1 states, plates move, which then cause the earthquakes. And claim number 2 says, earthquakes actually occur, and then that causes the plates to move. And so I want you to think about it. Choose one. Go ahead and answer that question as to why. Which claim did you choose and why? Go ahead and pause, answer that, hand it in, and then move on. Okay, so we're going to remember, we're still investigating the question, what is the land like underneath Earth's surface? And I'm going to review what we learned yesterday about Earth's surface. So you guys played with the simulation, and you were able to see what happens both on a surface view and a cross-section view, what's going on the surface of Earth and what's actually happening under the surface of Earth. And you also watched that video in which they were able to animate the removal of everything on the surface of Earth, and we got to see that Earth's outer layer is made of hard solid rock. Okay, so we know Earth's outer layer is made of hard solid rock, and then we just had those other 2 key concepts. Earth's outer layer is divided into sections called plates, and that geologists look for patterns in landforms and in geologic events in order to better understand Earth. So I'm going to have you guys go into the simulation today, and actually we're going to do it together. I'm going to try and get it in this video. And we're going to get some evidence to evaluate the 2 claims about earthquakes and plate boundaries, and we'll be able to decide which one is the most accurate claim, okay? Which one is the correct claim. So what we need to do first is discuss what kind of evidence we would expect to find. We have to come up with an idea of what we're looking for. We don't want to just run the simulation and just hope that something jumps out at us. Let's discuss what kind of evidence we would expect to find to support each of these claims. So claim number 1 says that the plate boundary motion causes the earthquake. So if you remember in Amplify, they have used the symbol of a black dot to represent earthquakes, right? So what would we expect to see first? Would we expect to see the plate move and then earthquakes if claim number 1 was supported? Or would we expect to see the earthquake and then the plate motion? Well, if we think that plate motion causes earthquakes, if we see that evidence that the plate is moving and then there's earthquakes, then we know claim number 1 is supported. Claim number 2, we would expect to see the earthquake first. So the little black dots need to show up, and then the plates will move. And so let's go ahead and run that simulation. Let's see if I can remember how I did that. I think I did this. Yes. Okay. Let me go here. Here. Yes. Perfect. Now we're going to go ahead and go to the simulating the earthquake. And, oh, whoops, I'm sorry, you guys. That's my teacher view. I want to show you your view. So we're going to choose region number 2. Okay. And we are going to create 2 little continents. It's easiest, I know you guys, it's really cool to kind of create these lands, these continents, but for something like this, we just really want, sometimes if you make it too much land, it just doesn't show you what you need to see. So this is great. We're going to go ahead and set a plate boundary. It doesn't matter what plate boundary we choose. We can do convergent or divergent. I'm just going to do divergent just because it's easier to, it's on the left side, whatever. And then we're going to go ahead and run it. And right after I run it, you're going to notice across the top, there's a toggle for me to put on for earthquakes. And so I'm going to do that. So you'll notice that the plate was moving first, and then we see the earthquake. Let me pause that. I'm going to rebuild it. Actually, I want to reset time. I want to build. I'm going to rebuild. And this time, I'm going to make my continents a little bit different. Set the plate boundary. This time, let's do convergent. So we can see on the top view, we see that plate boundary line. And then in the cross-section view, see, we still see that lime green plate boundary line. But with the convergent plates, they're going to come together. One kind of goes on top of the other one. I'm going to run it, and then I'm going to quickly click earthquakes. And you'll see it's running, and then we have the earthquakes. So without a doubt, claim number 1 is supported. Do you agree? I hope you do. All right, let's come back here. And we were right, where were we? I think here. So without a doubt, we know that claim number 1 is supported by the evidence that we got in the sim. And that leads us to our 4th and final key concept for the day. The plates of Earth's outer layers move. Go ahead and write that down and come back. Okay, let's go ahead and model a plate boundary. So the kids had a piece of paper in class, and I'm going to have you guys do this when you come back. And I think it'll be a little bit easier to explain it when it's actually here in front of you. This is a great way for me to assess your understanding of the key concepts that we've gone through and just the basic chapter question. What did the land look like where Mesosaurus fossils are found? So when you guys come back, I'll have you do this. Otherwise, no homework for you. Just continue to study your key concepts and your vocabulary. All right? Have a great day. Have a great weekend.